Thanks for joining us for today's webinar. I'm the Kotlin Marketing Manager for Education. My name is Ksenia Schneeweis, and you're now on our Kotlin by JetBrains YouTube channel, where we have a series of webinars created by educators and for educators and learners. In these webinars, we talk about teaching Kotlin and ways to integrate it into your experiences of teaching and learning. And today we have a very exciting topic, which provokes much debate. The topic is about what's the best introductory programming language. And we kind of know our answer here. As you can see from the title, it's Teaching Introductory Computer Science in Kotlin. And today's webinar is about maximizing fun and minimizing frustration. And I'm delighted to be joined by today's speaker, Geoffrey Challen, who is teaching associate professor at the University of Illinois at Urbana-Champaign, and he's the lead instructor for an Introduction to Computer Science course, CS 124, which is now the largest introductory computer science course to offer Kotlin as a language option, and it has 1,300 students in the course. So according to Geoffrey, Kotlin is an ideal choice for teaching introductory programming. But before I give the floor to Geoffrey to share more on this topic, I have a few things I wanted to mention before we start. So a recording of this live stream will be available on our YouTube channel. And after the event, you can watch it along with the other webinars of the educational series. Also, we are really looking forward to hearing from you. So please share your questions and comments in the chat, and we'll try to answer them as we go. And we'll also have a Q&A session at the end of the webinar. And one last thing before we start, if you can, please say hi in the chat. Please tell us where you are joining in from, whether you are an educator or a developer, and what was the first programming language that you learned or were taught at your school or university. All right, that's it from my side. Now, please welcome Geoffrey.
Hey, everybody. I'm really excited to be here. Thanks for the great introduction from Ksenia. So I'm going to talk a little bit today about our experiences using Kotlin in CS1. I'll give, so I'll talk a little bit about kind of the experiences we're having. This is our first semester where we're offering Kotlin as a language option in the class. It took us a little while to get here. I'll talk about that process. I'll make a case for Kotlin in CS1, right? Particularly compared with some other popular options that are in use today. And then we'll talk a little bit about sort of what we're doing in the class and some of the tools and resources that we've developed and some reflections on sort of, where we might go from here. I don't like to give long talks. It's probably the longest talk I've given in a long time. So if you have questions, please put them in the chat. Ksenia is going to be keeping an eye on that for me, and I've told her to just sort of break in and stop me at any point if there's things that you're curious about or if you want to have a discussion about any particular topic. So as Ksenia said, my name is Geoff Challen. I'm a teaching associate professor at the University of Illinois. My job is to teach, since I've been here, what I've been doing is teaching CS1. So I'll talk a little bit about what CS1 is in a minute. I also really love to program and build things. So that's a real passion of mine. And I'm in this great position where I sort of get to teach students how to code, but I also get to use my skills as a programmer and as a computer scientist to build new things to help them learn. So that's a lot of fun, right? I mean, we sort of tell students when they're getting involved in computer science, you can use these skills to kind of improve the world, make it a better place. And so it's really exciting for me to be able to use the skills that I have to help students learn. And so one thing I want to point out is that we're actually, if you're an educator and you're watching this, we're actually hiring. So the University of Illinois is hiring for teaching faculty for next year. This is a great place to teach and a great place to work. I've been teaching CS1 here since spring 2018. Over that time, the course has roughly doubled in size. So when I got here in fall 2017, I was teaching the course with a few other instructors. We had 700 students. This semester, we have almost 1,300 students. Typically, I teach the course solo. This semester, Colleen Lewis, one of my colleagues, has come on board, and she's been creating a lot of content. And that's been a lot of fun. So CS1, for those of you that aren't familiar with some of the nomenclature in this area, CS1 is the first course in computer science that includes programming. So there's also this idea of like a CS0 course that teaches computational thinking without introducing programming concepts. CS1 courses are, I think, super interesting, and it can be a really kind of challenging course to teach for a couple of reasons. One is that this is both, at least at Illinois, this is the first course for students in our major. So this is a starting point for a 4-year journey that they're going to go on, where they're going to learn all sorts of cool stuff. And so we want to get them started right. We want to set a good foundation for their future success. At the same time, it's also, for many students, the last CS course they'll ever take. If they're not a major, if they have kind of serious interest in the subject, but they're not going to go on in the field, this may be maybe the only one, or one of a very small number of courses that they're actually going to take. And so at the same time, as we're trying to build a strong foundation, we also want to teach skills that are independently useful. So we think about, if a student comes in and takes this class and never takes another CS course, do they walk away with some useful skills and sort of a good understanding of the field and appreciation for computer science? On a year-to-year basis, about 20% of, I should say only 20% of the students that take my class are actually CS majors. Most of them are non-majors. And the other thing that's tricky about this class is it brings in students with a variety of backgrounds. And I'll come back to this later, as I think one of the good reasons for using Kotlin. We have students that take the course that have never written a line of code before in their entire life. And then we have other students who have been programming for a while, and sort of everything in between. People that have done a little bit in high school, maybe taken one course in the past, but are pretty rusty. And so it's really important for us to be able to both accommodate these complete beginners, right, who wrote their first line of code in my class, but also hopefully provide a little bit of a good starting point for students that have a little bit of prior experience and are trying to sort of solidify their understanding. So let me talk about sort of how we got to Kotlin. And this is sort of a little bit of my story of how I got to Kotlin, right? Because, I'm a developer, and I've been doing this for about 20 years, building software and systems, before I got started in academia, and then during that time as well. And I've used, quite a few different programming languages during that time. So, I've, seen, I started off taking a course in C 20 years ago, moved on to other languages. And, one of the things that I've tried to do is keep my own skill set up to date. But it's also given me a chance to see how languages have improved, right? And see how technology has continued to progress. And I think that's something that, as a computer scientist, you really want to believe in, right? Like, we want to believe in the future. We want to believe that things are getting better and improving. And I think in many ways, that's really true. So when I got here in 2017, Java was not a language that I was using on a regular basis, but the course that I was assigned to teach, the CS1 course that I took over in the next semester, was taught in Java. And so, coming back to Java after a while away, I think I had a little bit more of an appreciation of some of the problems with the language. And as I started to watch students use Java, I saw even more of the stumbling blocks and the frustration and the inability to kind of do cool things and stuff like that. And so that made me start to think, maybe there are some better options. And I actually give credit to the co-instructor I had my first semester when I was at Illinois, a guy named Bill Chapman, who left very soon thereafter. But he was the first person to actually mention, hey, you might want to look into Kotlin. That might be a good choice for this class. So a couple of years later, I'm always building and updating tools that we use to support my courses. And I started using Kotlin, and I sort of really immediately found it to be a lot of fun. And so we started building like big pieces of our course infrastructure in the language around like summer 2019. And so that for me was kind of the genesis of starting to think, hey, this could be a great language for CS1. How do we get this into the curriculum? And this took a long time, right? So anyone who's contemplating this type of shift, I'll point out that we've devoted a fair amount of time and energy to this process, right? Like, I started thinking about this in summer 2019. The first time I taught a course in Kotlin was a little bit, here we sometimes call them side courses. It was something I taught on my own for fun, it wasn't part of our core curriculum. So that was in spring 2020. Obviously, there was a pandemic that started around then that I think at least a few of us have noticed. And so I got sort of sidetracked for a while by completely revamping some of our core Java materials for the next roughly year. But by spring 2021, I think we were really starting to see how Kotlin would fit in to the course. I built a completely independent set of Kotlin materials that followed along with the way that we do things in Java. And I'll show you a little bit later when we look at some of the materials used for live class, how that works right now. And then so finally, it wasn't until fall 2021 we actually got to the point where we're using Kotlin as a language option alongside Java. So, it may be a little bit of a sleight of hand to say that the course is in Kotlin because it's not. The students have the option to complete all of the course components in either Kotlin or Java. And it's funny. So, to me, this felt like sort of fast in terms of the progression of getting things working. But I think there were some students I work with that were really excited about Kotlin. They were like, Jeff keeps saying that we're going to have CS1 in Kotlin, and it never happens. So, but the stuff does take time, right? Like any change to a big course that's an important part of the program. One of the reasons why we have Kotlin as a language option is that, and I'm sure that any educators that are listening to this will know this. The choice of language in CS1 is super. It's like sort of a pot of a jar of worms that nobody wants to open, which I think is a little weird in a lot of ways. I mean, I've pointed out in my department that, my colleagues seem to care a lot more about what language I teach the course in than like what content I teach to students, right? But I don't know, it's sort of a weird touchstone for some other things that go on, right? And as soon as you open this question, everybody in the department has an opinion about it. A lot of faculty don't do a lot of programming. And so it's a little hard to kind of like always take their opinion seriously when you don't feel like they're actually on a day-to-day basis working as a software creator. And obviously also, the choice of language in early courses can have a big impact on the rest of the program, right? And so this is something that I think maybe a little bit of a misconception that it was just sort of my decision to do this. This was a decision that I made, after consultation with people in my department, and we had a lot of meetings and conversation and discussion about it. My original position was I wanted to move to Kotlin. And along the way, there was enough resistance to that idea that the compromise that we came up with was, well, we'll do both, right? And, obviously this is a compromise in quotes because it involved a huge amount of extra work on our part to kind of create all of this extra Kotlin content in addition to keeping Java around. But at that point, like Java was pretty well established in the course, and I had enough time and energy to work on this and had some materials that we had already created. And so it's been work, right? Like this semester, we've had a number of things that we've had to do kind of 2 times to support both languages, but it's definitely been pretty manageable. I don't want to put the blame solely on faculty as well for slowing down these type of processes, because students are also nervous about this, right? I mean, a lot of the concern from students comes from things like, will I be able to get a job? If I learn Kotlin and I want to get an internship, will anybody interview me in that language, right? And I think those concerns are reasonable, right? Although sometimes I think they're a little bit overblown, right? And then there's obviously these questions of permanence. Will Kotlin still be around in a decade? And from that point of view, I think that, Android's decision to start to use Kotlin has been a big boost, right? In the sense that it feels like it gives it a pretty firm foundation for the future. I do want to encourage people, though. I mean, if you're an educator and you're using, Java in your course, if you're using Python in your course, I really would encourage you to start thinking about other options, right? And I think that as educators, part of our job is to kind of make sure that we're rooting for the future. I was thinking back to my days in college. I took a kind of a second semester programming course in spring 2000. And that course was already using Java and had been for a couple of years. Java was released in, the first version 1 release of Java was 96. So it wasn't that long before Java started to see adoption in the classroom, right? In CS, in early CS courses. It's spring 2021, 20 years later, version 1 of Kotlin is 5 years in the past, and it's still taking a while, I think, to kind of seep into things. So I think we want to make sure that our courses don't get bogged down to the point where we can never think about using a new language, right? I mean, switching languages is hard, and it's not something you want to do constantly. But I do think that periodically we want to say, hey, this new language has a lot of offers a lot of improvements, has a lot of advantages compared with other options. So let's think about that. And I also think that academia has a role to play in helping establish these languages, right? I mean, if we start teaching, if everybody tomorrow said, we're going to teach CS1 in Kotlin, people would start interviewing in Kotlin because that's what students would know, right? So there is a little bit of a feedback loop that takes place here. The other thing I really firmly believe as somebody in technology is that languages are getting better, and they should be, right? I mean, if you think that, Python's like the best language that's ever invented, I mean, why should it be? We're learning things about how to design languages from experience. Computers have changed in ways that nobody could have predicted. One of the things I think that's true about Kotlin is, and some of the other newer languages in this space, things like Go and Rust, is there's an increasing reliance on the compiler to do a lot of really heavy lifting. And that makes sense because computers are so much faster now than they were 25 years ago. And compilation times can stay the same even as you do a lot more work to help the programmer by, for example, in Kotlin, doing things like checking for null, flow typing, and stuff like that. So I really do think, like I said, no one is going to switch languages in their CS1 course every couple of years. That's just too fast. It takes too much time and energy. There's too many materials that you want to build up. But we also shouldn't be using the same languages for decades, right? Claiming that they're a good choice, right? There are some better options starting to emerge. I think Kotlin is one of the best. All right, so the other thing, that I want to make sure I don't overemphasize here is that the choice of language in CS1 is just one of many factors that makes a good class. So if you have a poorly taught course, just choosing a good language isn't going to help. In contrast, if you have a well-taught class, you can probably get away with using a not so great language. And I have a couple of options. There's a couple of courses I'm thinking of that you've probably heard of that come to mind here, where it's a really well-run, well-structured, well-taught class that is for some reason using like a very, very outdated language that has a lot of downsides and drawbacks from the perspectives that we're about to talk about, right? So this is one of many choices that you make in an effective early CS course. But my question is simple, if you have a good class, why use a bad language, right? I mean, why continue to stick with a language that has a lot of limitations, right? Why not move forward and pick something new? All right, so let me kind of try to motivate the use of Kotlin in two ways. And this is sort of one of the lenses I try to think about, how do you choose a good language for CS1? For these early stage programming classes, I'm teaching beginners. This is an introduction to computer science as a field, not just to a language. And I never miss an opportunity to share this Fred Brooks quote, right? Because I think one of the things that we want to make sure that we instill in students early on is this sense of just the unbridled creativity that comes along with computer science, right? I've started to use the term software creation when I talk to students. I think software development sounds like someone else gave you an idea and your job is to just kind of make it work. But, learning how to program, learning how to build things, learning the basis of computer science really puts you in the position to express, creativity in one of the most powerful ways available to us today, right? It's just mind-blowing the kind of things that we can build and create. And you can see students doing this very early on. So, I want to connect students to this sort of creative energy, right? I want them to feel like they can build things. And this connects with their motivation, which, in this purest sense, I think people get involved in computer science because they do want to change the world, right? They want to see the impact of the things that they can do. Now, on the same, so CS1 should be fun, right? Maybe that goes without saying, but I've got one semester with my students, but I still do want them to see the beginning of a path that leads to a chance for them to have impact on the world around them, right? At the same time, programming is frustrating. And a big part of what we do in my class is really just sort of supporting students along the way, right? Like supporting students as they get frustrated, as they make tons of mistakes. Some of the frustration is inherent. So to the degree the frustration is due to things like, how do I implement this particular algorithm? That's fine, right? I mean, a lot of students early on struggle with, they understand how to solve the problem, but they have a hard time creating working code. That's cool, right? That frustration is good frustration. That is frustration that we want. That indicates that you're doing the work and you're learning. There's this other type of frustration that sometimes languages throw up that has to do with just sort of bad design. And that type of frustration we want to minimize, right? So I think a language choice can allow you to, not only create opportunities for students to have fun, but also minimize this sort of unnecessary frustration or friction that goes along with learning computer science. Before we talk a little bit about the aspects of fun and frustration connected to this, I just want to make a point about student motivation, which I think is an important part of this choice and this conversation. So, in the past, and I'm totally generalizing here, right? This is just my lived experience over 20 years in this field. When I was in college studying, and I didn't study computer science, so there's the gap. I studied physics, but I was taking computer science courses, and I had a lot of friends that were in the field. My sense is like a lot of the people at the time got into computer science because they just liked messing around with computers, right? They knew how to have fun, right? That's what brought them into the field, right? They just sort of liked programming. I mean, the kind of student that spends a lot of time on like LEET code questions just like solving these little puzzles, right? They like writing the code. That's totally okay. I'm not saying that's a problem, but I think that was more common in the past. I think today we increasingly have students with different types of motivation, right? So, maybe the kind I like more is this sense of, hey, I'm here because I heard this is a really powerful tool for changing the world and having a lot of impact. I want to learn how to do that. So these students really are interested in having fun in the sense of being able to have an impact. We also do have students who are increasingly career motivated, right? Who get into computer science because they know there are good jobs in the field. And for them, sometimes I think it's important for us to connect them to the fun, sort of high impact components of computer science, right? We want to make sure that they have an opportunity to experience that a little bit, right? And so I think, this shift, right, in terms of how students think about the field is important for us to respond to in terms of how we choose languages. All right, so I'm going to compare Kotlin now to a couple of other options. The two big ones that, at least in my mind, that I think are natural comparison points are Python and Java. And that's because those are really heavily used in a lot of early CS courses today. There are some other options out there. There are still courses that are using C and C++. I don't know why. Those languages don't seem to have very many selling points when it comes to introducing students to the field. And then there are other options that we could talk about more. And maybe people have questions. We could talk about like the Lisps and things like Haskell and highly opinionated languages and stuff like that. But I'm going to focus on Python and Java here for the sake of comparison. So how do you get students in CS1 to have fun? And this has become increasingly challenging as computer science and as the things that students build have become more complicated. But I think there's only really two viable options here, right, that really tap into students' day-to-day, minute-to-minute experience of computer science in their own lives. One is the web, and the other is apps. Like, that's it. If you think about what students do, how they spend their time, how most of us spend our time on computers when we're not sort of creating things, it's online or on your phone, And so there are other things that you can do, but these are the ones that are sort of the main line, right? This brings, the ability for students to create things right into their daily lives, right? This is something that you can show to your parents. This is something that you can show to your friends. And they'll get it. They'll be like, oh yeah, I install apps all the time. You built an app, that's cool. Like, that makes sense to me, right? These are the two ways in which I think that we have a chance to connect with students and their day-to-day experience of computing. So another way to think about it is that these two types of fun really don't need any sort of explanation to students. Students will get it. They'll be like, oh, I'm building a website. I use websites all the time. That makes sense, right? What are some other things that we do that I would either argue are maybe not as effective or require a lot more motivation, right? Well, having a student in an early course building like a pure backend application, right? Like the dark part, like the thing that, your web front end communicates with. I mean, that's cool. And I do that a lot and I enjoy it, but it's a little bit hard to sell, right? It's hard to motivate. It doesn't necessarily seem fun right away. It's like, wait, it doesn't do anything. Like where's the button I push, right? Like, how do I, whatever, it doesn't, it is a part of the computing universe that students are living in, but it's not so directly connected to their day-to-day experience. Another one I like to pick on is like text-based games, right? I mean, yeah, there's some nerds out there who love to play text-based games, and that's totally cool. But most people most students that come into my class have never played a text-based game and don't want to play text-based games. Again, 20 years ago, this was probably a lot more common. Today, the fact that you even know about this type of thing probably means that you're intrinsically motivated, right? You're here because you already are into this stuff, but it doesn't help really create impact for students that aren't already convinced that computer science is cool. I've got a couple of other examples up here, but I'll just keep going. I think that, one of the things that's so exciting about Kotlin, and this is also true about Java, is that Android, right? I mean, to me, that is an immediate chance to give students the ability to build cool stuff. I think some people might say, you can do Android programming in your first semester, and we have been now for years. We were doing this even before we started working with Kotlin. We were doing it in Java. Is it as straightforward as I would like? No. Does Kotlin help here? It does, right? But we've had good experiences with not only having students do projects where they build Android apps, but even in the past, having them do sort of independent creative projects where they would build their own app from scratch. And this is something that is achievable within the bounds of a 15-week introductory course. I think that particularly with respect to the other options in this space, this really stands out to me, right? So I think Kotlin wins big time when you think about fun and impact, right? And, another way I sometimes describe this is food for the journey. It takes a long time to get good at computer science and programming, right? I mean, I'm still learning how to do this 20 years later. I don't want to diminish that. You're certainly not going to be able to teach students everything about the field in one semester. That's ridiculous. But if you can get them started with something cool, then it helps sort of like carry them through all the hard work they're going to have to do later on. It's like, oh yeah, I can still build apps, and some of them get involved in doing it on the side. And this really helps sort of like sustain them as they continue their journey in computer science. All right, so now let's talk a little bit about frustration. And here's the place where I get to pick on some other languages just briefly. I'm running a little bit behind schedule. So, but when it comes to frustration, right? For me, the main connection is sort of with syntactic difficulties. And so I've got a bunch of these. I've written up a post about this on my website, and I've got a bunch of different examples that you can go through and interact with to help make this case. But let me skip to one of my favorites, right? One of the kind of the real blooper reel type things for Java. Okay, so again, I've been teaching Java to students for years. I've watched them struggle with various things about the language. This one has to be probably one of the worst. And remember, these are beginners. So some of you are much more experienced programmers, and some of this stuff may seem like not that big of a deal to you. But when you're just getting started, mistakes like this can be really, really frustrating to deal with. So, let's talk about equality in Java. You start off teaching Java at a very basic level. You teach students how to use primitive data types, and you teach them this double equals operator for equality. And it does what you think, right? Like this works, and it's the right way to compare primitive types in Java. At some point, you have to start transitioning students to thinking about objects. And when you do, you're supposed to compare for equality using dot equals. And this is something that, you tell them and you remind them, and they make mistakes based on it. But here's the problem. The first object we frequently introduce in CS1 is a string. And strings because they're easy to work with, you can initialize them using a literal. It's a really powerful data type because it allows you to store text, which is something that's very bound up in human experience, right? And so you start talking about strings in Java, and you tell students, okay, we're working with objects now, and you're supposed to use this dot equals method call to compare for equality. And the problem is that with strings, you can frequently get away with using referential equality checks, right? You can frequently get away with using this double equals operator because of these stupid lower level details of how Java optimizes for strings, which make perfect sense from the perspective of someone who's like more sophisticated and understands how these programs work. But from the perspective of a beginner, it's like, wait, you told me to use dot equals. I kept using this, double equal operator, which also, by the way, is a lot more convenient, looks nicer, it's just like, it stands out even more easily on the line. you told me to use dot equals, but I forgot. And as we were working with objects, I kept using it for strings and it kept working. And so it sort of reinforces this bad behavior. And again, like all of this at a high level to an experienced programmer makes complete sense, like why it works this way. Like this is an optimization that Java does to improve the performance of string use within Java programs. But from the perspective of teaching students who are just starting out, right, where, you know, getting into bad habits early can be really problematic, and who also don't understand anything about string and turning. Like you don't want to try to explain to a beginner, well, you know, the reason this works this way is because when the compiler runs, it finds all the strings, and it's like they don't care, right? They're just like, wait, why does this work? You told me not to do it. The other big one that I'll point out that I also that also throws me about Java is this, right? So this is Hello World in Java. Look at this program, right? And think about if you walk into a CS1 class and you've never programmed before, and I'm like, here's how we get the computer to just print some text. You know, I need a class, I need a static void main method, I need this string argument, right? What is, and so immediately from the very beginning, there's all of these really uncomfortable, weird concepts that you're throwing at a student just so they can print something to the terminal, which shouldn't be a difficult thing to do. We have some workarounds for this that we've built into my class, but it still frustrates me that this is sort of the day zero program that students see in Java and a lot of other courses. Because, you know, when you start off at the beginner and you're like, oh, just ignore all that other gobbledygook. Like, even if you think about system.out.println, like thinking about why the name of this method is what it is really challenging to explain to someone who just got started. There's dot notation, you know, it's like 30 characters long for no reason. I mean, it's just, I just wanted to print a string, you know, like why is that so hard to do? This type of stuff, you know, creates this friction. It creates this unnecessary type of frustration that affects beginners as they get started. I'll just use one more example. I've got a bunch of them here. I'm sort of picking the greatest hits. Oh, containers in Java are terrible. I mean, like, I just want to work with a list, right? But no, I need like 3 imports. List, like this is actually the correct way to initialize a list literal if you want to modify it in Java. Like, why, right? You know, why do I need to do this all so that I just get a list that I can modify and use to show students how lists work? But the one I really like are classes. And so, you know, we want to, when we start talking about objects, we want to introduce them to students in a way that's useful. We want to say, hey, when you have more complicated data types, you can actually create new data types within the language using this class syntax, right? And this is something that shouldn't be hard, right? I have 2 variables and I want to bind them together essentially. I've got something that has both a string property and a numeric property, like an int property. And I just want to create a new type that combines those 2. Here's the Java code that I have to write to get that to work, right? And this even doesn't have a bunch of useful methods. Like I haven't implemented equals, I haven't implemented hash code, there's no toString method. You know, look at this. Like all this, I had to do all this just so that I could create a person object with 2 fields. Right? It's like 20 lines of boilerplate, and it would be longer if I implemented those other helpful methods. And so what happens is, you know, students come away with this idea that classes are like a big deal. Like a class is like a heavyweight abstraction, rather than thinking like, hey, new data types are really convenient. You should create them whenever you need one, right? Whenever it helps solve the problem, right? Not, you know, in Java, they have to be in their own file if they're a top level class. Like there's all this sort of ceremony, right? That was a word that my former student Ben Nordic introduced to me that I love, right? It's just like Java is full of ceremony, you know. I mean, there's that other joke, right, which is that, you know, Java programmers seem to get paid by the line, you know, and so it's like, hey, I'll write this class and then have IntelliJ auto-generate all the fields for me, and then I can sit back and collect my paycheck for the day. So, you know, I picked a couple of these examples. You're welcome to go through the others. I haven't picked on Python as much. Python does better in some regards here. Python's classes aren't all that great, right? There's still a little bit of ceremony here. It's a little bit better than what we needed to do for Java. The data class syntax that they started introducing in new versions is nice. But, you know, Kotlin is, I mean, this is awesome, right? Just being able to do this, and then we can start working with that instance of the person. We get equality, we get copy, we get a nice string method. This is really, really helpful. All right, go back and we'll talk a little bit about, let me briefly talk about a couple of other considerations or other reasons that I like Kotlin. When we teach CS1, at least in the States, we typically have students that come in, the two languages that students tend to know when they come in are Java and Python. Java because it's taught in high school here, and also Python because it's taught in high school. So we have high school sort of advanced placement courses in the United States that students take that teach both Java and Python that are sort of, offered in association with this sort of accreditation agency called the College Board. We already have skill gaps in CS1. We have students that are more experienced than others. And dealing with those skill gaps is actually really, really important, because the typical experience of a beginner in CS1 can be to feel like they're surrounded by students that know more than they do. And sometimes that's true, but it's because those students have more experience. But a lot of times the beginners tend to think, oh, everybody is catching on a lot faster than I am. Like they tend to look at someone who's sitting at the table next to them. Maybe that person has had 2 or 3 years worth of programming in high school, but the beginner doesn't know that. And they're like, oh, they're picking this up so quickly. What's wrong with me? Maybe I'm just not cut out for computer science. And you're like, no. You've been doing this for 2 weeks. They've been doing it for 2 years. Of course they're better at it. You'll get there too. Just give yourself time, right? Keep working on that. I think choosing a language like Kotlin that nobody knows, right, because it's not taught in high school, might help with that, right? Because now everybody is encountering a new language. Now it's easier to pick up a second language than is your first language for sure, but I think that Kotlin can play a helpful role here. The fact that Kotlin's a newer language and has just overall better online resources and documentation, I think is also important. If you look at the type of stuff that you can find for Java, I mean, it was good like 10 years ago, but it hasn't always aged very well. And I think Kotlin looks like a language that has put a lot of time and energy into making sure that there are great tutorials, great documentation. Some of this has to do, I think, with the fact that modern languages are competing for attention, right? I mean, Kotlin is not the only sort of JVM follow-on language that interoperates with Java. And so it's like, you're competing for hearts and minds with people that might pick up Scala or Groovy or something like that, right? And so I think that competition for developers helps push these online resources forward, because that's something that people are going to evaluate, right? It's like, if I get started with Kotlin really easily, I may forget to look up Scala because I got so excited about Kotlin, I started building cool things, and off you go. The fact that Kotlin has just really excellent support for multiple programming paradigms, I think is also really exciting. So CS1 courses evolve over time. Sometimes they get handed off between different faculty members that have different ideas about how to teach things. And so the fact that, in Kotlin, you can do like really strictly object-oriented programming, but also really functional style programming as well, I think is really cool. And I've actually had some conversations where I've seen people talk about these ideas of, creating multi-course sequences that are all in Kotlin, where in the first semester, you might do like basics and object-oriented stuff. And then semester 2, you can switch gears and do a lot more functional programming in the same language. So rather than forcing students to change to another language, which causes them to need to learn new syntax and new idioms, you stay within the same language, you switch paradigms, and you allow students to see the differences between approaching problems, from a strictly imperative perspective versus approach them from a more functional perspective. And of course, like the tooling for Kotlin is also great. I mean, this is a JetBrains, webinar, so I feel like, obliged to do a little bit of company store type stuff. But this is actually for me like a real selling point. Like, the fact that you can sort of tell that Kotlin has been created by people that do a lot of their own development, right? In terms of the fact that it's fairly unopinionated. It has these really beautiful idioms. The tooling support for it is awesome. So that's great. Right? That's a big help. All right, let me briefly do just a couple of. Well, maybe I'll skip this and we'll come back, and I'm happy to show this off later. Let me talk a little bit about how things are going in my class right now. So we're at Thanksgiving break. We have about a week left, so we're pretty close to the end of the semester. This is our first semester teaching offering Kotlin as an option. So the way my course is set up, students do daily lessons. Oh, let me full screen this. And what we've done is we've essentially compared, we've created 2 tracks for the class, one in Kotlin and one in Java. And they're almost identical. There's like a couple of places where there's like these little divergences. Like next week, we're going to teach streams in Java. And in Kotlin, of course, we teach like, stream operators like MapReduce filter and some of the higher order programming concepts, right? But in general, like if you look, almost all the materials are identical, which is nice. And actually, I think that's a good thing for anyone who has a course in Java to keep in mind, right? In the sense that you can migrate to Kotlin and keep kind of the same conceptual progression that you've used up until that point. So our lessons are structured with like lots of interactivity. I'll do a brief demo of this in a sec. At this point, we have about like 450 Kotlin either small videos, or we have this new interactive component we've created called a walkthrough, which is essentially like an animated editor. There's no video, but you can hear somebody explaining a particular concept, and you can see as they manipulate the editor contents. What's cool about that is that students can pause and they can play with the code themselves and run it and stuff like that. For the Kotlin materials, there's about 17 people that have contributed to those. The way we have things set up for my class, all the course staff can also contribute their own explanations of things, but our Kotlin materials are just getting started. And so right now, the primary contributors are me, and then Colleen Lewis, who's been co-teaching the class. She's done a lot of work on the Kotlin materials as well. In contrast, like for Java, we have about twice as many sort of explanations and a lot more contributors because students have had more time in Java. We've been teaching the course in Java for longer, and students have had more time to contribute materials and staff. So my course has a heavy focus on basics of programming and lots of chances for students to practice. So every day, at the end of every lesson, there's a small programming problem. And then we have weekly quizzes where students do a few more of these problems in a proctored environment over the course of, the dog is making noise. Over the course of the semester, this semester, they're going to do about 200 of these small programming challenges, sort of like either in an unproctored setting or a proctored setting. And we've also actually been developing this library of small Java and Kotlin exercises. We have about 500 problems in that library right now on like every topic that you can think of, from object-oriented stuff to basic comparative programming to recursion to interface usage to anonymous classes. Like it spans the entire gamut. So that's something that we would certainly be excited about collaborating on with anyone else interested in using the language. So we have about 1,300 students in the class at this point, and about 250 of them are using Kotlin. So that's about 20%. I consider that for the first semester to be pretty good, actually. I had no idea what this number was going to look like. I think I would have been disappointed if it was like 2 or 3%. I think I would have been shocked if it was 50%, but I think 20% is a good starting point. Part of that, I think, is the students are responding to the fact that this is our first time using Kotlin. So, my course staff are typically drawn from students who took the course in previous semesters. And so those students know Java, like that's what we used to teach. And so a lot of my course staff are still really only prepared to help students in Java. An increasing number of them are coming onto my staff with Kotlin experience, and that'll continue to happen, right? As we teach more students Kotlin, we'll be able to recruit them onto the course staff. And so we'll have a staff that's more balanced and more bilingual, which I think will really help encourage students to use Kotlin instead of Java. I just for fun, I look at the grade breakdowns by language, and the Kotlin students are doing like, I don't know, 1 percentage point better, right? The students in my class are doing awesome, by the way. So I think our median grade right now is about a 94 out of 100. The Kotlin students are doing like a tiny bit better, but I think that's largely a function of the fact that Kotlin seemed to appeal a little bit more to students with prior experience. And so I think that's probably what's driving that. After the semester ends, like we have a ton of data to look through. So I was tempted to do some analyses for this talk, but I was like, no, I should wait. I don't want to get them wrong. But, I'm super curious to see things like, are the Kotlin students able to solve our homework problems in fewer attempts? Like, are they performing better when we normalize for prior experience? So we'll be able to dig into this. But to me, the fact that even despite the fact that we have a lot less, on some level, less support and fewer materials in Kotlin, the students are doing as well, I think is a real testament to the language. So let me talk a little bit about some of the stuff that we've built. I'll just put this up here because I want to wrap up soon. So we've got a bunch of tools that I'm happy to share with any educators that are interested in Kotlin. We've built like a playground background that we use for all the examples. And it's really sort of become, this tool has become this like general purpose toolkit for doing all sorts of language related stuff. We have this small problem library that I mentioned a minute ago that we use to create new homework problems. One of the things that students are always asking for is more practice, right? Which is fantastic. I want to be able to provide that. So we've actually done a lot of work. Most of this also all implemented in Kotlin, right? So we've done a lot of work to create a tool that allows us to really rapidly author really good homework problems for students to use. We have a lot of experience with sort of like just how to teach Kotlin, sort of a certain conceptual progression, particularly transitioning from Java, how to auto-grade Android programming assignments in Kotlin and stuff like that. So again, if you're curious about how to do this, or if you'd like to pick our brains or share resources or tools, like please, feel free to get in touch and I'd be happy to help. So, we're going to keep using Kotlin in 124. I don't know if we'll ever be able to get rid of Java, or maybe at some point, we'll swap out Java for like another safe language, right, that appeals to students that aren't as future forward, right, like maybe something like Python. But I'm curious to see kind of what the adoption of Kotlin will look like over the next couple of years as we continue to use it alongside Java. So I wanted to, since I have a chance to talk here, and I have hopefully at least a few people from JetBrains or who work on Kotlin listening. I thought I would just, make the case for a couple of things that I think, JetBrains could do, or the Kotlin Foundation could do to support the language in academia. Overall, I think Kotlin's doing a fantastic job. One of the big questions that people have when you start bringing up a language like Kotlin is this a safe choice for students that want to go out and get internships? Right. And so I think, continuing to encourage employers to offer coding interviews in Kotlin and make that known, right? Make sure that people know that, hey, now Amazon is letting you, complete the coding problems for their interview screens in Kotlin, right? I was trying to find a list before this talk of like all the different employers out there who allow you to use Kotlin, but I couldn't find them, right? And so maybe I didn't search hard enough, but if the Kotlin Foundation or JetBrains could put that up as part of the Kotlin educational resources, that would be awesome. The online tools and resources are pretty great, right? I think there's a few places where there probably could be some small improvements there, but in general, like it's fantastic. The other thing too is don't underestimate the fact that these transitions are non-zero effort, right? Like taking a course, particularly a well-established course that's using Java or Python. It's been built up for multiple years, and moving to a new language is hard. It takes time, it takes energy. You're sort of discarding a lot of prior work to start fresh. And so, academics are always begging for money, right? So I'll fall into that category as well. But the cool thing about this, I think, again, speaking from my perspective as a teaching faculty, is that you don't have to, it doesn't necessarily cost a lot. Right? Like if you, they had grants that said, okay, we're going to give you like, I don't know, $5,000 or something if you agree to take an existing CS1 course and transition it to offering Kotlin or being taught in Kotlin, you'd probably get some people that would sign up for that, right? Is that money going to like pay for all the effort required? No, right? But once you, it's like a lot of grants work, right? Once you give people the money, they feel sort of obligated to do it, right? And it's enough where they can go to the department and be like, oh, okay, we have this new exciting opportunity to do this and stuff like that. So a little bit can go a long way here. For any students that are watching this, please, I'm here as a representative of the University of Illinois. It's a fantastic place to go to school. We're doing a lot of work in the curriculum that's really sort of future oriented. So please consider applying here to do your undergraduate work here. And if you do, hopefully I'll have you in class and you'll have the option to use Kotlin in the class. So, all right. So I'm going to take like 2 minutes and just kind of show you a little bit about how we do things in my class. So this is this series of lessons, right, that I was talking about. And you'll notice that in most cases, like the 2 lessons are the same in Java and Kotlin, right? So we had a lesson before break where we went through some examples of how to implement a map, right? This is earlier in the semester. We're talking about sorting algorithms, trying to find a place where there's a little bit of a divergence here. There aren't many, like most of these are identical. So in most cases, what we've been able to do is take the lessons we were using in the past for Java and rewrite them for Kotlin, just sort of continuing the same conceptual progression that we've been using. Here we go, here's one, right? So, Kotlin doesn't have the static keyword. That has a similar concept. And so, we have a lesson on static for Java, and that day, the Kotlin students talk about companion objects. Let me click on a lesson here, right? So here's an example of a lesson let me make this a little bit smaller so I can turn off. It's in preview mode. You get to see some of the things. So this is how our materials are heavily based on interactivity. So we really want to give students a chance to write code and experiment, right? I mean, I always feel like show, don't tell. So a lot of times I'll say, okay, how does this work? Let's see, right? And we'll do a small example that allows us to see what happens. So here's an example of a video. We also make heavy use of these interactive walkthroughs. So I'm going to play one of these. I don't think it's going to. Oh, it's really loud. Okay. So here's an example, and what you can see is that as I'm typing in the editor, and as I'm highlighting things and running the code, students can watch. And at any point, if they want to try things themselves, they can pause, and then they can use they can edit the code, they can run things on their own. And so this is one of the primary ways that we use to deliver the material. And it's fun because it provides opportunities for other people to contribute. This is obviously not a great choice because you'll see that this is a lesson where it looks like I'm the only person that has added content to it. Let me see if I can find a different one, or I'll show you what the Java ones look like. The Java ones are older, and so they have a lot more. Like here's a particular concept where there's like 4 different explanations from different core staff. This is Colleen, who's the co-instructor this semester. This is me, and then we have a couple of core staff members that have talked about, hey, here's a particular example where something can throw, and what do you do about that? So anyway, we've got a lot of sort of I think at some point I put up a list of sort of our course brag page where we talk about a lot of the new technologies that we've created to support the class, but this is just like a little bit of a brief glimpse. All right, I have talked for a long time. I'm going to shut up now, and I will take questions from Senia or from anybody in the chat.
Thanks, Geoffrey. I think it was a really great presentation. I was writing down some questions, and I was just really impressed by the whole ecosystem that you built for teaching the course in 2 languages. That's really impressive. So now I've written down a couple of questions, and I'll read them to you in a moment. But for those who haven't already submitted their questions, please do so now. We're looking forward to hearing from you and answering your questions about Kotlin as a first language, teaching Kotlin, or anything else you might have. So here are a couple of questions and comments that I've written down. So the first languages mentioned in the chat that people learned computer programming in were Perl, C languages, Java, Pascal, Basic, Fortran. So these languages, not modern languages, not many there. But that's just a comment. Now there was a question from Smith about how hard it is for students to set up IDE to start with Kotlin. And Smith was using a playground to teach them, but was asking whether there was any syntax highlighting REPL for Kotlin.
Yeah, so it's a great question. So the structure of my class is a lot of the work that we do is done right in the browser. So the first time students set up, because I think that IDEs are great, right? And the JetBrains IDEs for Java and for Kotlin are fantastic, right? As well as Android Studio, which is built on top of the same technology. I tend to make the argument that for people that are just getting started, I think the IDE can get in the way. And so what we do is we have students work in this very stripped down playground environment where there is no there's syntax highlighting. It's sort of broken, unfortunately. Like we're using the built-in syntax highlighting for the ACE online editor, and the Kotlin, whoever contributed the Kotlin version it's either broken or it doesn't work quite well with our playground or something. So that's a little disappointing, but there's some syntax highlighting, and hopefully someone who knows the system better than me will fix it at some point. So it'll just start to work again. But in terms of things like auto completion and stuff like that, I mean, I tend to think that students do better starting without those type of helpful things, and just sort of encouraging them to type the code, right? Like type the code yourself. You're writing small, I mean, the problems that we're having students do for my class on a daily basis are maybe at most like 10 or 20 lines of code. Type the code yourself, right? Get used to doing that type of thing and not on heavy reliance on, the IDE. I think for beginners too, sometimes like the IDE in its attempt to be helpful can kind of just totally end up confusing them deeply. So I was working with someone the other day and they were trying to set up an empty list. And on the right side of the initialization, instead of writing new array list, they wrote new list and then they hit return, right? And of course, the IDE thinks that you want to create a new anonymous implementation of the list class. And so it spits out this 100-line long prototype implementation. And the student is looking at this like, what happened? I mean, they have no idea what just went wrong, right? And it's just a small mistake, right? That is easy to make. I've made it before, but sometimes, I use an IDE all the time, right? So I certainly don't want to claim that they're not useful. They're tremendously helpful. But I think for people who are just getting started, I think that they're certainly not required, right? And I wouldn't want to use a language that really required an IDE. It's interesting with Kotlin because I have seen people say the language really seems to require an IDE, and our experience has been that that's not the case. Our students seem to be able to write Kotlin code particularly fine in an environment with limited syntax highlighting, no auto completion, none of that type of stuff. And I think that, again, when you're getting started, that helps. Once we start working on Android, we do have them use Android Studio, obviously, because there's like no other way to do it. I have been always really impressed with how well, and I think it's just a testament to Android Studio and how good the documentation is, that, I've got 1,300 students in my class, and I would say 99% of them are able to set up Android Studio on their machine without any problems, right? And so we help the ones that are left over kind of like work through strange things that happen or weird errors and stuff like that. But in general, I mean, I think the fact that this is a tool that's used by so many developers just means that the documentation is awesome, right? And the tutorials for getting started are great. And so we don't have a lot of work left to do.
Okay, thank you. Another question from a Kotlin educator who actually teaches an Android class in Kotlin from the University of Leeds. Nick Efford was asking what was the knock-on effect for other modules. If students in CS1 choose Kotlin, does this force other faculty to allow for coursework in their modules?
Yeah, so, and I should have mentioned this when I was talking about sort of how we got to Kotlin in my class. One of the things that gives me a little bit of freedom in my CS1 course is that I don't have a lot of downstream dependencies. So, and I don't endorse this approach, but at the University of Illinois, students start in my class, they take now either Java or Kotlin, and then they end up grinding through like multiple semesters of C++. And from the perspective of fun, I have a lot of concerns about that language choice, and I've been talking about this with my colleagues. And so I'm not convinced that having students do like a whole solid year of C++ is really a good choice. But that's what we do. But what it means is that, there's not like a second semester course that's also in Java or a third semester course. I think the next course in the department that's in Java is actually at the 400 level. So it's like multiple years downstream. It's not required. I haven't talked to them. I've been communicating with the people that teach that class a little bit about various things, but I'll have to talk to them. I mean, I would hope, I mean, when you think about how curricula work, at some point you want to stop teaching languages, right? I mean, we teach languages for the first couple of years, but once students get to the third year of the program, the fourth year of the program, I think they should be expected to take a course and just pick up a new language as they need it, right? Like if I wanted to teach a 400 level course and I wanted to teach it in Rust or something like that, I shouldn't have to teach Rust for 2 months, right? I should just be like, look, here's a week, here's the basics. You guys are all, mature computer scientists now. Like you might get a job in a language you don't know very well, and you might have to pick it up on the fly. So go for it, right? So I hope that some of our more advanced courses that use Java, one of those courses actually does do Android development. I would hope that they would be able to say, okay, fine, we'll do Kotlin too. Why not, right? I mean, we're not really teaching a language at that point, right? What we're doing is we're teaching Android development, and that's a set of concepts that shouldn't be directly tied to one language, right?
Thanks. Another question about using Android and the balance between spending time on computer science fundamentals and Android specificities. How do you balance that?
Yeah, it's a great question. And let me speak a little bit to like where I feel like this question is coming from, right? Because I feel like the concern here might be, students are getting distracted by the fun of Android programming, and they're not like learning kind of basic computer science principles that you want them to learn in the CS1 course. So first of all, my experience is that we've been able to do both, right? So my course actually does, we do a lot of sort of, foundational computer science concepts, include kind of sorting algorithms, recursion. We actually added some content on graphs this semester for the first time, which we'd never done before, and students seemed to eat it up. They had a lot of fun with it. So you can do that, right? And then they're also doing the Android programming alongside of it, right? So I think that with the course that's ambitious enough, you can get this to work, right? I've had some people look at my class and say kind of, how you guys are covering a lot. And I'm like, yeah, we see very healthy numbers when we look at final grades, when we look at things like drop rates and stuff like that. So it certainly isn't being done at the expense of the students in the class, particularly the students who come in with no experience. We bring them along. But I think there are some intro courses that I feel like aren't quite doing enough, right? I mean, you've got 15 weeks in my case with the students, they pay a ton of money, right, for the class. I don't want to do half of the material that we could do because I don't know, right? Because I just feel like it's my job, right? I mean, they sign up to learn, and I want them to know as much as they can, right? Obviously, there's a limit, right? I mean, it's only 15 weeks. They can't learn everything. The other thing we've been doing this semester with some guidance from the course staff. So we've been using Android now for several years in the class. And I do think that our Android assignments had gotten a little bit sort of integration heavy, right? So focused on sort of challenges involving getting two parts of the app to work together properly, right? That aren't as core CS concepts, right? One of the things we've done this semester is we actually have more components of the project, the Android project that students do, that are really like basic programming tasks, right? That I would expect a student to be able to do, that really do kind of push on core computer science competencies, like the ability to use basic data structures, the ability to implement basic algorithms. So we have students doing some work where it's like, it's part of the Android project and we end up using it either in the UI or in some other way, but really it's almost like a problem that you could take out of Android and assign in a completely different context that just involves things like working with maps, understanding how to traverse a data structure, how to understand how to transform a data structure into a slightly different form and things like this, right? So I think there is this possibility to, not only introduce students to some of the basics of Android programming, but along the way, continue to push on some of these. So for example, one of the final steps they're doing next week when we get back from break is essentially graph traversal, right? It's in the context of this data set that we've given them that they're using to do other things with the UI, but the core algorithm that we're having them implement is graph traversal, right? And so there is an opportunity to have some overlap there, right? Where you're not just kind of like showing students how to build an app, you're also continuing to give them practice with sort of core computer science competencies and things like that.
Okay, thanks for the great overview. Another question is rather comment about teaching two languages, Java and Kotlin, at the same time. There is a comment that students are trying to understand the concept and need to remember two pieces of syntax and might be confused by which is which. And the suggestion is to teach two very different languages, for example, Kotlin and Haskell, to showcase different ways of programming.
Yeah, so let me just, I think there's a little bit of a misconception underlying that question. So students don't take the class in both languages. Students choose one language, and then, you know, a student that chooses Java, for example, can take the course and never see a piece of Kotlin, right? A student that chooses Kotlin can take the course and never see a piece of Java, right? You know, the students, so for example, the quizzes that they take, if you choose the course in Kotlin, you take a quiz that uses Kotlin examples. If you choose the course in Java, you take a quiz that uses Java examples. If you choose the course in Kotlin, you're doing work on the project in Android in Kotlin, right? All the test suites are in Kotlin, all the code that we've given you is in Kotlin. If you choose Java, it's all in Java. One of the things I will point out that's made this possible, which is kind of neat, is this big restructuring of the course we did during the pandemic. So the class is still being taught asynchronously online. So I don't lecture, right? That's why I was saying before, like, this is the longest talk I've given in a long time. I mean, I used to be, you know, on stage in the largest auditorium on campus 3 times a week, you know, teaching students Java. I don't do that anymore, right? We took the course and we completely redesigned it along this daily lesson model. So we provide a lot of support for students. And next semester, we have some in-person activities that we're going to start up that are like tutoring hours and stuff like that. But structurally, this opens up this opportunity, right? Because again, if you're a Java student in my class, you wake up, you go to the lessons page, you do the lesson, it's in Java. You finish the problem, it's in Java, right? You show up to take your weekly quiz, it's in Java, right? You open up your MP, the project, right? We call the machine projects here at the University of Illinois. It's kind of a weird term, and I'm sure not everybody uses it. You open up the project, it's in Java. So it's not, now, are some of the students peeking at the other language? I'm sure they are, right? And we offer them that opportunity. So if you're a Java student and you're done with your lesson and you kind of want to see the same concepts in Kotlin, you can do that. Like, we don't hide things to a degree that students can't kind of explore the other language if they like. But, you know, because otherwise, if you were trying to do this as part of a more traditional course, I think it would create some problems, right? Because it's like, okay, now I have to do 2 lectures, one in Java, one in Kotlin. I don't know how many people are going to sign up for each class. But because of how we restructured the course, this makes this possible, right? And I've even been sort of, I don't know. I can't tell if this is something I'm doing just to keep myself busy or really a good idea. I'm like, oh, we should do Python too. Like, why not, right? Because, you know, now we could put up a series of Python lessons, Python quizzes, Python homework. I mean, it's a lot of work, right, to generate all the new content. But it's not, the course isn't in both languages, right? And I certainly agree with the point, which is that if you were teaching a course like this in 2 languages, I do think that you would choose ones that were more syntactically different. I took a course when I was at university years ago that taught 3 programming languages, and I think we did C++, Java, and Lisp. And honestly, C++ and Java are a little too similar, right? But at least Lisp is like way out there in terms of syntax, right? So yeah, hopefully that explains what we're doing a little bit better. It is a little weird, right? I don't know if, I haven't looked around very much, but I think we might be one of the only courses, we're certainly one of the biggest sort of highest profile courses that's offering students the option of languages, right? Not like we're going to do both Java and Kotlin, but like you can choose one or the other.
Thanks. One question from myself. Do you about the teaching mechanism? How does this work? Do you get at all any one-on-one time with your students, or how does this work?
So I don't necessarily do a lot of that, right?
Mm-hmm.
I spend my time creating the materials, sort of working with my staff, keeping all of our systems online and stuff like that. We do have, and again, this is something that we created during the pandemic. So we have a system that is built through the website where students can get one-on-one help from staff pretty much all day, right? We have staff signed up. I have a large core staff. I have about like 40 or 50 paid staff members, and then a bunch of students that are doing it for course credit to kind of learn how to be a course assistant. And so normally I would show you the schedule, but I just cleared it for Thanksgiving, so it's empty right now. But normally, like pretty much from 9 a.m. to 11 p.m., we have somebody on our help site. And so a student who is struggling with that day's lesson or needs help with the homework or with the Android project could go on the help site, get in line, and they receive assistance from a staff member. So from time to time, I jump on the help site as a staff member, partly because it's fun, like I enjoy helping students. It also helps me kind of understand how students are doing, because it's like I kind of see what people are struggling with. But the students are typically pretty surprised, right, when I end up helping them. They're like, oh, like it's the professor. I'm like, yeah, I do this from time to time.
Wow, that's a wonderful example of remote teaching and scaling of the course. Really,
it works. I mean, it works really well, but I think one of the reasons it works so well is because I think our online materials are already really good. And so we've looked at some of the data from our help site, and I don't know, I mean, 90% of the students almost never use it, right? But that's great, right? Because they're learning material from the lessons, from our interactive materials. And then it also means that it makes it a lot easier to help the other students who do need it, right? Because there's fewer of them, and the staff to student ratio is better, right? So yeah, no, the whole system works really well. I'm pretty proud of it. And I think, the pandemic has been such a difficult event for so many people. I think it's been difficult to kind of talk about some of the good things that have come out of it, right? But in the past, I mean, I think like a lot of other courses, if a student needed help, we said, oh, we have office hours, come to the computer science building down to the basement, and, we'll help you. And you kind of think from a student perspective, it's like they're, in their dorm, in their bathrobe, right? And like getting it makes it sound accessible, but just like getting to the computer science building in order to get help. Like, let's say if they have a quick question, right? Something that's just going to take 5 minutes. It might take them an hour to get back and forth, right? For 5 minutes worth of help. And so next semester, the plan is we're going to restart some in-person activities, assuming that it continues to be safe. But we're definitely going to keep this site running, right? Because I think for students that have quick questions, it's awesome, right? It's just super convenient for everybody.
Right. It's a huge transformation from even 2 years back.
Yeah.
Yeah. Another question, let me just find it, about whether you've considered using our Tools plugin to solve problems in the IDE.
Yeah, I'll admit, like I tend to be sort of bad at using other people's things, right? Like I enjoy kind of creating our own stuff. I have, like, as I was prepping for this, I was sort of looking around and I was like, oh, I'll check out. And you guys do have these amazing resources. So one of the things that that's important for me from the perspective of an educator is being able to generate content, right? So, the problems that we've created for our students to work on, like I said, like those problems are super valuable, but they do take time and energy to create. And so the system that we've built to author those problems, right? Maybe we could get it to fit in with the plugin for Kotlin. I don't know, right? We could look into it. Like I said, I'm also not 100% convinced that I want students working in an IDE right away, right? Because I do think there are some pedagogical advantages to having to type the code out yourself, right? Like not being able to rely on all the autocomplete and suggestions and things like this. I mean, I think sometimes, we say for students who are just getting started, you want them to get to the point where certain things are just like under their fingers, right? Like, I don't want to think about having to write a loop, right? I just want that to be, it's almost like you learn human languages, right? I mean, at the beginning, you're kind of obsessed with letters, right? Like every letter has to be formed very carefully. And then you start writing words, and then eventually you're working with sentences and larger chunks of text. And so I think, keep in mind, our students are at the letter stage, right? And it's always really fascinating to me. One of the things that's at least fun for me as an educator, and having done this for a long time, being able to work with students, is just you realize how much the experience of working with computers has changed you, right? So the kind of mistakes that my students have a really hard time seeing, like the difference between like a single equals and a double equals, right? Like I can see that from like 30 feet away now, right? Because I've just been looking at code for too long, right? And it's a mistake in like every single language. And a student will be staring at it and be like, I don't know what the problem is. And I'm just like, it's right there, And so you just, but these type of things take practice, right? I do think that I don't know if anyone's studied this, but I do feel like the visual cortexes of programmers are probably different, right? Because you've just learned like braces, right? Like mismatched braces. I mean, students can struggle with this for 10 minutes and you're just like, it's right there, right? I mean, so that these type of things, I think working in a simplified environment helps students, instill some of these abilities. And then like, again, for doing a real project, I'm like, use an IDE. I mean, everybody does this, right? Like I said, I use them all the time. I don't do any programming outside of it, or I try to do as little as possible outside of an IDE environment because I want all those benefits, right? But I think there's a question about like, how do we bootstrap students in a good way that gives them kind of the foundation for success? And for me, like having them start with the IDE is not always the best thing, right? I mean, even so, I think IntelliJ is a fantastic IDE. The other thing to keep in mind too is that these are complex pieces of software, right? I mean, as soon as you open up one of these IDEs, it's like you're at the controls of the 747, right? I mean, there's a bunch of buttons and boxes and, and I think again, the IntelliJ IDEs do a great job of sort of organizing information and trying to simplify stuff, but it's still like a power tool, right? You don't take someone who's trying to learn how to fly a plane and get them in the cockpit of a 747. Like that's not where you start, right? You start with something that has the minimal set of controls that you need, and you teach them there first, and then eventually they build their way up to that, right? So I think that can be a little bit intimidating for beginners. I like just having them, okay, there's a text box on the website that you're typing into, right? And that's all you need to worry about, right? We also, I mean, when you teach a big class, you inevitably find students who have, through no fault of their own, right? It's just like they push the wrong button in the IDE once and they can never figure out how to fix it, right? Like it changed some setting that's really weird, or it opened a window that they don't want to see. And again, it's not their fault. Like they were just trying to click on something and they just missed by a few pixels, but suddenly they have this weird problem that you have to have them solve. So anyway, we try to avoid stuff like this. This, I think, falls in the category of like that avoidable frustration, right? As much as I like IDEs for real sort of more advanced, complicated programming.
Thank you. Yes, I totally can relate because I'm trying to learn programming myself, and IDE and the buttons that change sometimes from a tutorial that I watch. This is always a struggle that takes 10 times longer than in the supposed time estimate of an educator. Mm-hmm. So another question here from the chat is about whether you know if some of the students stick with Kotlin after the courses for hobby or professional settings.
I don't know. It's a great question. I've taught, the first course I taught in Kotlin was in, to just like a subset of students was in spring 2019. This is by far the most students that I've taught Kotlin and the earliest in the program. So I think it'll take a couple of years to kind of get a sense of how things work as students go through the pipeline. And I'm curious, like one of the things that you learn as an instructor is that there are these really long feedback loops that happen in computer science programs and in any program, right? In the sense that when you make a change, so I'll give an example. When I started teaching the course, I started requiring that students, this was in Java, right? Spring 2019. I started requiring that students follow the check style guidelines, right? That have to do with things like spacing, brace placement, stuff like that. I mean, there was like a massive amount of howling that went up, right, from the students, like in the first semester. They're like, oh, I took AP, they told me to do this, and why are you grading me on this? It has nothing to do with correctness and stuff like that. And I was like, we had a lot of really good reasons for it, right? Which is why everybody uses linters. But semester after semester, the volume just went down, right? Because what happens is like students realize that, oh, this thing that you were doing that I hated at the time, right? Like actually paid off downstream. Like it really helped me when I went to my next course. It really helped me when I went to my next course. They start to be on staff for classes and they start to see kind of like some of the reasons for it. So one of the reasons that we use check style is, imagine you're a staff member on my help site. You're working with one student for 5 minutes, another student for 5 minutes, another student for 5 minutes. If every piece of code looks different, right? If every one of them has like different conventions, indentation is obviously the biggest problem with student code, right? If you can't read code if it's not indented properly, right? So if everything looks different, there's a lot of extra mental overhead for you to just help the student. And so one of the nice things about check style or KTLint, which we use now for Kotlin, is just everything looks the same. And that really helps the staff, and that's worth it, right? Because, I don't want the staff to have to be figuring out, what level is this block at, right? Because the student's code is completely unindented. I want them to be helping the student with like the computational thinking, right, that they're struggling with. So I expect this will happen with Kotlin. So we'll see, right? Ask me in a couple of years, right? After these students have sort of moved their way deeper into the program, they've had a chance to interview for jobs. I think that, as I suggested, I think that anything that, as Kotlin becomes more well-established for programming interviews and stuff like that, I think that'll help. I think right now, though, if you learn Kotlin, you might have a little bit of an advantage for some jobs, right? If the job wants someone who knows Kotlin, right? Like you're that person, and you guys have made some great progress, like getting Kotlin taught in, computer science programs, but it's still far from common, right? And so if you're going up for an internship and the internship wants somebody with Kotlin experience, like you're that person, right? And you're not going to have a lot of competition, right? So hopefully that'll help. But yeah, the long-term impact of this, we'll see, right? It's going to be fun to watch.
Thanks. Another question is about admission to your university. Do you have any special advice other than going and checking out the website for admissions rules?
Yeah, it's really hard. That's what I would say. Yeah, like the admission to computer science here is really selective. I think we accept like around 10% of applicants at this point to the computer science program. So, the university does offer a variety of mixed degrees, right? We call these CS plus X. So we have a degree in CS plus statistics. We have a degree in CS plus crop sciences, right? Like this is an agricultural university. So, and there's actually some really cool agricultural tech, right, that's being built right now that you can see out in the fields around here sometimes. So also consider those programs, right? If you take one of those programs, you get a fantastic grounding in computer science combined with, complementary study in some other field. And I think some of those degrees, if I was choosing a degree now, I would be very, very tempted by computer science plus statistics, right? Because it's like you get all the computer science stuff, but then you also get this sort of rigorous training and sort of data analysis and how to think about that. And I think those are sort of like the two modern superpowers, right? It's like how to build things using computer science and then work with data. I think a lot of computer scientists pick up some of the data science stuff on their own, but having that be part of your official degree program, I think would be pretty cool. So I'd say look into those options as well, right? If you're interested. But it is, Illinois is a top 5, top 3 school, depending on how you rank them, and so like it is tough to get in here. I'm not gonna sugarcoat that.
Thanks. And I know that we're all over an hour now,
It's fine.
so let's maybe take some last questions. I have two more in the
Sure.
queue, and those of the viewers who would like to ask their questions, please do so now, and then we'll wrap up.
Sure.
So the questions I have for now are about specific computer science concepts that you have found easier to teach students with Kotlin in comparison to Java. What are
Yeah.
they?
Yeah. So, and this is not something. So keep in mind that what we've done so far with Kotlin is that we took a course that was in Java, and we've run a Kotlin course alongside of it. And the results are you end up being a little bit handicapped by Java, right? Because whatever we do in Kotlin. So for example, when I work as I'm designing our Android project, right? I have a solution set that I'm working on, right? And I've told my staff I always work on the Java solution set first, because the Kotlin version is going to be a lot nicer, right? And if you start with Kotlin, it's easy to build something that's like too hard to do in Java, right? So I always start with Java. I come up, okay, here's what I want students to do in Java, and then I translate it to Kotlin for the Kotlin solution set. If I was if we might get to a point where we have a kind of a Kotlin first course, right, where Kotlin is how we organize things, and then Java is what's sort of put alongside of it. There's a couple of things about Kotlin that I think are super nice. So the working with containers, right, in Kotlin, lists, sets, maps, massive improvement over Java, right? From just simplicity, you don't have like 5 imports that you need to do, initialization, syntax, right? I mean, bracket syntax is awesome. And I talk a little bit about this in my blog post. I have mixed feelings about operator overloading in general, but the ability to support things like just bracket syntax for lists and maps is awesome, right? So that's really, I think that's one of the areas where Kotlin just has a massive advantage, right, for intro CS. Trying to think. And then I think if I was teaching the course in Kotlin, I would do more with streams. And stream processing, sort of pipeline type higher order programming concepts. We do those very, very late. Like we have one lesson next week, and it's really kind of enrichment at that point. But part of the reason for that is just how terrible I shouldn't say terrible. I mean, they exist, right? Like the stream operators in Java. But I was thinking back when we were talking about IDEs, and I was like, that's one of the places where I totally rely on the IDE. Like, I don't think I could write a stream pipeline in Java without an IDE, right? Because the syntax is just weird, right? It's like, I want a list, and there's some collectors to lists, and I don't remember how to do it. So I just start typing to lists, and I hope that the IDE helps me out. Whereas Kotlin syntax for, MapReduce filter type stuff is just awesome, right? So I think that, if we were doing the course in Kotlin and didn't have Java alongside, we'd probably do more functional programming ideas, right? We'd probably do more work with higher order programming. We talk a little bit more about things like maps and first class functions and function wrappers and stuff like that. So, and that's stuff that, you just, again, you can do it in Java, sort of, right? But the syntactic, issues start to raise their ugly heads there, right? So that's something that we don't do as much. But yeah, it's a great question. I mean, I think if we started with Kotlin and worked that way, there'd probably be some pretty substantial differences that were arise. But there's not a lot that are coming to mind right now, other than the ones that I've already pointed out.
Thanks. And I think we have the last question. I don't see any more questions in the chat, so we can wrap up with this great question about whether it's possible to deploy your version of the online learning platform that you built for courses at other places. Is it open source? I think, as far as I remember, it is. We can share.
Not really. Okay. So I'd like to get there, right? We're working on this. So first of all, if you're interested in this type of project, please let me know, right? I mean, it's always easiest for me to work on something when I have the knowledge that there's someone who's actually excited about using it, right? like when you're just trying to build something for some imagined audience, it's a little bit abstract, right? And I tend to like the projects that end up at the top of my list end up being things that like somebody wants, right? Sometimes that person is me, right? But I already got the course set up, right? So I'm good there. The current course website is kind of a hot mess, right? In the sense that it was like developed very quickly and, you know, pandemic times, and I was sort of learning a lot of things as I went. And so I'm a little bit like embarrassed by it, right? So I don't have any plans to publish it. It also has a lot of other kind of materials in it that I don't want to share. Like it has all the quiz contents for my class, and I can't publish those because they have solutions in it and stuff like that. So anyway, there are some just stupid implementation issues here. But if you're excited about this and you want to, like, I would love to do the following. I would love to have a class that I maintain with a collaborator, right? Particularly at another institution. So if someone else said, hey, I'd like to teach Kotlin, let's work on materials together. The materials are designed so that anybody can contribute explanations and content. So my colleague, Colleen Lewis, who came on board this semester, what she did, essentially, like the platform was already in place. And so what she's been doing over the course of the semester, she's been going through and she's been recording her own explanations of things, right? Her own videos, her own walkthroughs. And I mean, her videos are always better than mine. Like mine are terrible, right? Like me with a whiteboard and a cat comes and sits on it in the middle or whatever. So Colleen's videos are awesome. Like they're way better. And her walkthroughs are good too, because frequently when you ask two instructors to explain the same concept, we just do it a little differently, right? We think about it differently. We use different metaphors. So it is easy to set that up so that, you know, like if you were at some other university and I was here and the courses were similar enough in structure, you could record a bunch of your materials. My students could see you explaining stuff. Your students could see me explaining stuff, and my staff and Colleen and everybody else who's already contributed. That would be pretty cool, right? I'd be super excited about that. There's not, you know, in my opinion, there isn't enough sort of cross-institutional collaboration in this type of way, right? A lot of us are kind of like siloed at our own places, building our own tools, creating our own content. And there's some reasons for this, and you know we're already over time, so I don't want to ramble on about this for too long. But I'm not sure they're great reasons. But I think that the structure that we've put in place, I think, is amenable to this type of collaboration in the sense that, you know, you can make the course feel like yours. I can still make the course feel like it's mine. But students get the best of both worlds, where they have more backup content, more voices, right? I mean, that's the other thing too that I'm really passionate about, is just making the course speak with a more diverse set of voices, right? I'm hoping that in a couple of years from now, when students come and take the class, they hear a lot less from me, right? And they hear a lot more from my staff, a lot more from a diverse set of collaborators, right? That'll take time, right? But we're already getting there, right? I mean, Colleen's contribution has been super important. So now there are sort of two primary voices in the course, and there are definitely room for more.
Wow, that's great. That's a great perspective that you are looking into, and I think that's a great way to wrap up this webinar. Now that we've covered all of the questions, I'd like to ask today's viewers, those who are still with us, to share their opinion about our webinar today, to share with us what they've learned, whether this topic was relevant to them, what other topics they would like to hear in the future. And I'll share a link to a short survey in the chat. So please, those of you who are still here, you can go to this little survey and fill it in. And those of you who have registered for this presentation, you will get a follow-up email with a link to this recording, the links that I've been sharing in the chat, the link to the great essay Geoffrey created about teaching Computer Science 1, where there are the links to the slides and to the course website that Geoffrey is teaching. So yeah, just look out for that email, and please fill in the little survey in the chat. And once again, Geoffrey, I want to thank you for the great presentation and answering the questions. You were very generous to give us more than an hour of your time during your holiday break, and we really appreciate that. Thanks so much for sharing the information about your unique course. I think it gave us all a lot of new ideas on how we can transform, how the educators can transform their courses in the new reality of remote teaching. So yeah, thanks so much for your faith in Kotlin. And I really liked the quote from the essay that also I think is great to sum it up. Always bet on the future. If you're not willing to, it's hard to enjoy a life in technology. And yeah, I really like that quote. And thanks, Geoffrey, for your time once again.
Thanks everybody for the great questions. It's been a lot of fun.
Thanks, everyone. Have a great evening. Bye.